In this task, we will discuss various vector search strategies and the metrics used to measure the similarity between vectors. In vector search, there are two primary strategies to identify similar vectors: exact search and approximate search. As its name suggests, exact search employs a brute force method to find the nearest neighbors, leaving little to no margin for error. This approach aligns with what the k-nearest neighbor method typically does, symbolizing exact search. Conversely, with approximate nearest neighbor (ANN) search, you find less accurate nearest neighbors, but you gain in speed. In other words, you trade accuracy for speed. Within this search strategy, we find several indexing algorithms. We refer to them as indexing algorithms because their output is a data structure called a vector index. This vector index assists us in maintaining all the necessary information for an efficient vector search. Among these algorithms, tree-based methods, like Annoy by Spotify, stand out, alongside proximity graphs, clustering systems, LSH systems, and product quantization systems spearheaded by Face, developed by Facebook. Hashing and vector compression also play significant roles, with the scan algorithm developed by Google leading in vector compression. In summary, we have two distinct search strategies: nearest neighbor search and approximate search. The former is more accurate, and the latter is faster, albeit less accurate. Next, let's discuss the metrics we will employ to determine whether two vectors are similar. We achieve this through distance metrics or similarity metrics. With distance metrics, we commonly measure the L1 distance, known as Manhattan, or the L2 distance, known as Euclidean. The Euclidean distance is usually the preferred choice and is most widely used. A larger distance metric indicates that the vectors will be more dissimilar. In other words, there will be a greater distance between the vectors, and they will therefore be less alike. Alternatively, we can also measure the similarity between vectors using the cosine similarity measure. A higher similarity metric indicates more similar vectors. Thus, we can use either of these two metrics to determine the similarity between vectors and understand the degree to which they resemble each other.